Right, this is a diodes question. I know that because straight away I've been given these diode graphs here. There's two diodes, a D1 which is red and D2 which is green. And they've got two different graphs. So this is the D1 graph and this is the T2 graph. And straight away I know this has a threshold voltage of 2 volts for D1. This one has a threshold voltage of 3 volts. This is where it goes up at 3 here and 2 here. Alright, so let's set up a circuit only using D1, like this. Calculate the current shown by the ammeter. The first thing I do is, with these ones, is draw on that I know there's going to be 2 volts used up here. Just to make sure this is the positive, this is the negative, current will flow around this way. Yep, the current's going to go the right way, so there will be current that flows. It's not, they haven't put it in backwards. If 2 volts is used here and there's 12 volts total, that means there must have been 12 minus 2 is 10 volts used up here. Calculate the current measured by the ammeter. The ammeter is over here. Right, well, the current goes along. The current, if we could figure out the current through D1, we'd know the current in the ammeter. But according to this, well, the current can be pretty much anything. So that's no help. But if we follow the current back, if we can work out the current that goes through this guy, it's the same current that goes through here, the same current through here. So we need to be able to work out the current in the resistor. So this is just using your simple V equals IR. If I rearrange that to find I get I equals V over R. And I put a 1 beside it, so I know that I'm looking at the current through through 1, the voltage at 1, and the resistance at 1. So the voltage here was 10 volts and the resistance is 100. 10 divided by 100 is 0.1 amps. And put that into milliamps because they've asked for it in milliamps. Is 100 milliamps. You times it by 1,000 to put it into milliamps. So there's my 100 milliamps, the first one. Right, I've copied and pasted the same guys over, but here's the question for B. Alright, so now they use D1 and D2 in the circuit and calculate the voltage across R2. So R2 is over here. Right, well what I know is in each arm of the parallel, this is a parallel circuit, in each arm of the parallel, over both of these things is 8 volts. Each arm is always the same in a parallel. So 8 volts over both of them. And I know, again, 2 volts for D1 and 3 volts for D2. So I've got 8 volts over both of these, then I must have 2, this must be 6 volts. Because 8 minus 2 is 6. 8 volts over both of these, but minus 3, that leaves 5 volts left for D2. So the value of the voltage across R2, is 5 volts. 5 volts. It's worth 2 marks. We've done our working up here, so let's just see C working on diagram. Alright, again I've just copied and pasted the same things, and we had, let's just write what we had here. We had 2 volts, we had 3 volts, we had 5 volts, and we had 6 volts. Calculate now the current through the ammeter here in milliamps. Alright, well this is outside the parallel bit, this is back in the series bit. So the current comes around, it splits up, some of it goes that way, some of it goes that way, goes through, comes back around, and then it joins back together again. So to work out the current here, we need to work out the current through here, and we have to work out the current through here, and add them together. So let's worry about this side first. This is the one side. The current through the side, well, we can't really work it out using the D. We've discussed that before, the diode. But we can work it out using the resistor, because the current through the resistor will be the same as the current through the diode. We've got a voltage for the resistor, and we've got a resistance to the resistor. So it's the same as our 2A question. We can just use this to work out the current through this arm. So I equals V over R. So I1, because I'm looking at number 1, which is 6 volts divided by 100 ohms. which is 0.06 amps. In my second arm I do the same thing. I'm going to use I2 equals V2 over R2, and that is 5 volts over 150 ohms, and that's 0.033 amps. And so the total is those two because they join here, added together. 0.06 times 0.033 equals 0.093 amps. And it's asked for it in milliamps, so this is what I did before. From amps to milliamps, you times 1,000, which gives me 93.3. Well, you didn't have the 3 there. 93 milliamps. And last one in the series. Right, here's those same graphs again, but the question is down the bottom. The diodes are now tested independently to see how they convert electrical energy to light energy. Each diode is supplied with a current of this. The power output of D1 is that. The power output of D2 is that. So when this is the output, that's the light that's coming out. The light that's coming out. Alright. Use calculations to determine which diode converts the largest fraction of electrical energy into output energy. So when we're comparing like this, we're looking at efficiency. This is an efficiency question. And efficiency equals the power out over the power in times 100. Because we're comparing between D1 and D2, what I'm going to do is I'm going to set up like this, and it's like a competition. So we can easily see what's happening on this side and what's happening on this side. I want to work out that formula. So do I have the power out for D1? I do. Power output at D1 is 150 milliwatts. Let's write that in watts. That's 150 milliwatts in watts because I divided by 1,000. Cool. Do I have the power input for D1? No, I don't. So what I need to work out is the power input. But I know that it's just voltage times current. Now, what's the voltage in D1? Does it say it here? It just says a suitable voltage. But if you go back a few pages to your graph, D1 only ever takes 2 volts. Well, that's its threshold voltage. So 2 volts times current of 100 milliamps. 100 milliamps is 0.1 amps. 2 times 0.1 is 0.2 watts. So now I've got enough information to do the equation here. Efficiency, it equals power out, which is 0.15, divided by power in, 0.2, times 100. I do that on my calculator, I get equals 75%. So now we just need to do the same thing with D2. We've done the hard work of figuring out what we need to do. It's just a case of doing it now. Power out for D2, they give it to us. 200 milliwatts. 200 milliwatts in watts is 0.2. The power in is VI again, which equals the voltage of 2 is 3 volts. And the current, same current as before, 100 milliamps, 0.1, which equals 0.3 watts. So the same formula before. Efficiency equals 0.2 divided by 0.3 times 100, which on my calculator gives 66%. Right, let's compare which is the winner. This one is. So D1 converts larger fraction.